fx equals square root 2x plus 1, and x is bigger than 1. What's the range of this function? It's only for 1 mark, so you should be able to see it directly. What's the range here?
The range of 2x plus 1.
Square root 2x plus 1. What is the range?
Minus square root 5 is greater than
Square root 5 to infinity. Open or close? Well, the smallest value is root 5 because x starts at 1 and it increases. If I didn't say x starts at 1, if I just gave you x's all allowed values, what would the range be? 0 to infinity, including 0. That would be for the x. That's the domain. I'm talking about the range. If I didn't give you the domain and I said what is the maximum domain, yes, minus a half to infinity. But the range would be 0 to infinity in that case. Anyways, it's only 1 mark, so you should be able to see it directly. Part 2 is find the inverse. Y equals root 2x plus 1. Y squared equals 2x plus 1. X equals y squared minus 1 over 2. And we have our answer. Inverse function is x squared minus 1 over 2. Right, part 3. I give you gx and I give you hx, and I ask you to find what gh of x is. So gh of x is g of 3x minus 2, which is 2 times 3x minus 2 squared minus 3 times 3x minus 2 plus 4, which would be 18x squared minus 24x plus 8 minus 9x plus 6 plus 4, which is 18x squared minus 33x plus 18. Is this function one-to-one or many-to-one? If the domain, so the domain here is 0, what am I doing? Domain equals 0 to 2, including 0, 1, 2. There's a couple of ways to do this. A very quick sketch is probably the quickest way to do it because it's a quadratic. And by very quick, I mean just find where it crosses the y-axis and the minimum. So to find the minimum, we make the derivative equals 0. So that would be 36x minus 33 equals 0. So the minimum is at 33 over 36. And the y here would be 18. And here is 0. And here is 2. And here is 1. And here is 33 over 36. So the graph would look something like this. So I can see that it's not... What's wrong? I found a quick graph of where across... You can see why this is 18, yeah? Yeah, because I put x as 0. What's wrong, Tal? You still asleep? Come on. If I put x as 0, what do I get for y? Yeah. No breakfast? And then you see how I got this one? Derivative equals 0 gives me the x here. Yeah, I'm just doing it the quickest and easiest way because I am tired. One could use completing the squares. One could do this, yes? I could use it.
Can you use it now?
You would like me to use it? Fine. Doesn't make it any better. Yeah, and he's ruining it. Alright, I'll take 18 out. This is going to be ugly. Minus 33 over 18x plus 1. This is 18. I have no idea why you want to add. Right. 33 divided by 18 divided by 2. So that would be minus 11 over 12x, not x, squared. And then we have to do 1 minus the square of that, which is 11 over 12 squared is 121 over 144, isn't it? So that would be plus 23 over 144. 18x minus 11 over 12 squared plus 23 over 8. So the minimum is at 11 over 12 and 23 over 8. By the way, 33 over 36 is 11 over 12. So it's the same answer I got a moment ago, but much longer. What?
What are the roots of the equation? Just out of curiosity.
You figure it out, alright? You know how to find roots of a quadratic. And by the way, this doesn't actually have roots. The discriminant is negative. Right, so if I draw this now, here is 0, here is 1, here is 2, here is 18, here is 11 over 12, and 23 over 8, and here is the quadratic. Is this 1 to 1? It's not, but we need to prove it. So, the easiest, if it's from 1 to 2, 0 to 2. The easiest way to prove that it is not 1 to 1, that it's many to 1, is by taking two values of x and showing that you get the same value of y. So if here it looks like it's 1, but sorry, it's actually a little bit to the left of it at 11 over 12. If I move even a little bit to the left and a little bit to the right, I should get the same answer when I sub it in. So let's try x1 equals 10 over 12 and x2 equals 13 over 12. If I substitute these back into my fx, Hussein or Ali, do you have this written down here? Well, I'll remember it. What is it? 18x squared minus 33x plus 18? Is that right? You don't sound confident. Right. Okay. Ali, please put 10 over 12 into this and tell me what you get. Hand this over to him. I can't be dealing with this right now. And guys, can you please put in 13 over 12 and tell me what you get? And you've got to get the same answer. No, wait. Now what did you get, Ali? Okay. What did you get? Just give me the calculator back.
Check it before you read.
What did you get? 30. Right, hang on, sorry. Hold on. 11 over 12. If I move a bit to the left, that's 10 over 12. And if I move a bit to the right, I'm sorry, this should have been 12 over 12 here. Yeah. It's disgraceful. Right. So can you please put 1 into this instead? Thank you. So here, if you put 10 over 12 in, you get 3, and if you put 1 in, you get 3. So therefore, it is many to 1. What's wrong? No. 18 minus 33 plus 18 is 36 minus 33, which is 1. Who knows? Yes? That's okay. That's okay. Just make sure you get something to eat before physics, okay? We'll see how it goes. Okay, so it's many to 1. B, part 1 is a plot. Okay. So the function we wish to plot is y equals 2 absolute 4x plus 2 minus 3. So first we'll make x equals 0 and we'll get y equals 1, I think. Yes. Now we should find, so this is where it crosses the y-axis. The next easy point to find is the vertex, which would be minus a half and minus 3 is the vertex here. If you remember how to find the vertex, you make this 0, that gives you the x, and this will be the y. Just like in semester 1 when you did finding the vertex by using the method of completing the square. The more difficult one to find is when y equals 0. When y equals 0, and to find what the x is, we have 2 already. We have 2 absolute 4x plus 2 minus 3 equals 0. Absolute 4x plus 2 equals 3 over 2. That means 4x plus 2 equals plus or minus 3 over 2. Or its squaring method. 4x equals minus 2 plus or minus 3 over 2. 4x equals minus 2 minus 3 over 2 minus 7 over 2, or 4x equals minus 3 over 2, no, sorry, 3 over 2, yeah, minus a half. 3 over 2 minus, yeah. So you get x equals minus 7 over 8 or minus 1 over 8. So now we have these 2 points, minus 7 over 8 is 0 and minus 1 over 8 is 0. So the 4 points are this one, 0, 1, and minus a half, minus a third. Okay, so let's draw it. So I'm dealing with lots of fractions. So on my x-axis, I'll just go from 0, minus 1 to 1 on the x-axis. And then on the y-axis, I see the biggest numbers, 3. So I'll just go to 4. Okay, so we have 0, 1, minus a half and minus 3. This is the vertex. Minus 7 eighths and 0, and minus 1 8 and 0. Yeah, I put them all in. If I label them, it'll be clearer. A, B, C, and D. So here was the vertex, which was D. Here are the 2 x roots, A and B, and then here's the y-intercept, C. Yeah. Like the method of completing the squares, you make the part inside the absolute 0, and then you take the value at the end as the y. Lastly, solve this equation. Twice absolute for x plus 2 minus 3 is less than 0. In other words, when is this graph less than 0? Well, if you look, it's here is when it's less than 0. So in other words, x must be between the A and the B answer, which is that and that. So the answer is x is between minus 7 over 8 and minus 1 over 8. And that's it for 1 mark. This was for part 1. Question? No?